In the present lecture, we will discuss the procedure to remove an artificial variable by the Big M method. Big M method is one of the method of removing artificial variables from the basis. In this method, large undesirable, that is the unacceptable penalty, so large undesirable coefficients to artificial variables are assigned from the point of view of the objective function. So in this method, large penalty coefficients are assigned to the artificial variables. If the objective function z is to be minimized, then a very large positive penalty is assigned to each artificial variable. Similarly, if the objective function z is to be maximized case, then a very large negative penalty is assigned to each of these artificial variables. The penalty is supposed to be designated by -m for the maximization problem and +m for a minimization problem. Here m is the greater than the 0. The Big M method for solving an LP problem can be summarized in the following steps. Let's see the procedure of the Big M method by the step by step. So first step is express the LP problem in the standard form by adding slack variables, surplus variables and artificial variables. After that, we have to assign a zero coefficient to both the slack variables and the surplus variables. Then assign a very large coefficient +m in the minimization case and -m in the maximization case to the artificial variables in the objective function. Step 2 is initial basic feasible solution is obtained by assigning 0 value to decision variables x1, x2, x3, etc. Step 3 is calculate the values of zj minus cj in last row of the simplex table and examine these values. If all the zj minus cj values are positive, which means zj minus cj greater than or equal to the 0, then the current basic feasible solution is optimal. Second condition is, if for a column, let's consider any kth column, zk minus ck is most negative and all entries in this column are negative, then the problem has unbounded optimal solution. Third case, if one or more zj minus cj is negative less than 0, then you have to select the variable to enter into the basis with the largest negative zj minus cj value. Step 4 is determine the key row and key element in the same manner as discussed in the simplex algorithm for the maximization case. So after determining the key row and the key column and the key element, then step 5 is continue with the procedure to update the solution to each iteration till optimal solution is obtained. So here I have to observe some remarks. At any iteration of the simplex algorithm, one of the following cases may arise. First case is if no artificial variable appears in the basis and the optimality conditions are satisfied, then the current solution is an optimal basic feasible solution. if all the Zj minus Cj is greater than or equal to the 0 and there is no artificial variable in the basis, that solution we are calling as the optimal solution. So second case is if at least one artificial variable is there in the basis at 0 level and the optimality condition is satisfied, then the current solution is optimal basic feasible solution through degenerated, which means all the Zj minus Cj is greater than or equal to the 0, but artificial variable is appears in the basis, but its xb value is the 0. So the present solution is the optimal basic feasible solution through the degenerated. So next third case is if at least one artificial variable appears in the basis at positive level and the optimal condition is satisfied, then the original problem has no feasible solution. So the solution is satisfy the constraint but does not optimize the objective function since it contains a very large penalty capital M and is called the pseudo optimal solution, which means if all the Zj minus Cj values are greater than or equal to the 0 but artificial variable is appears in the basis and its xb value is the positive, it should be the greater than the 0, then we are calling as the problem has no feasible solution. So this is the procedure for the Big M method to remove the artificial variables. So in the next lecture we will discuss the some example problems for the Big M method. Thank you.